I like to think that me being behind in my video making is charming, so I want to start this video by telling you about something that happened in March of 2026. Because of my interests, it showed up all over my recommendations at the time, but I don't think it got nearly enough attention, broadly speaking. In the United States, the FCC quietly reshaped the consumer router market in a way that affects pretty much everyone with a home network. And once you understand what happened, this little SBC on my bench starts looking a lot more interesting. Welcome back to That Explains Everything. Today we shrug at import restrictions and look at loading OpenWRT on a cool little single board computer. In March 2026, the FCC added consumer routers to what they call the covered list, their official list of equipment that poses an unacceptable risk to national security. The practical effect is that new consumer-grade routers produced outside the United States can no longer receive FCC equipment authorization unless the manufacturer gets a conditional approval from the Department of Defense or Homeland Security. Now, you might be thinking, okay, so this is aimed at TP-Link and the Chinese brands, right? And yes, that's where it started. TP-Link had grown to something like 65% of the US home router market, and there were documented incidents of Chinese state-sponsored groups using compromised home routers as footholds, including a specific firmware implant designed for TP-Link devices that gave attackers persistent access without the owner ever even knowing. But here's the part that doesn't get reported as clearly. This rule doesn't care where your company is headquartered. It cares where your router is produced. And the FCC's definition of produced is broad. It covers manufacturing, assembly, design, and development. So a router designed in San Jose and built in Vietnam, that's a foreign-produced router under this rule. Google, Asus, Linksys, it doesn't matter if the name on the box is as American as apple pie. If the factory is overseas, they're in the same boat as TP-Link for any new models. And that's basically everyone. Industry analysts estimate that nearly 100% of consumer-grade routers are manufactured or assembled outside the United States. So this rule, as written, affects almost the entire market. Who's actually in the clear? Starlink is the only major consumer brand with significant domestic manufacturing, producing their routers and satellite dishes in a facility in Bastrop, Texas. Everyone else is just scrambling for a conditional approval or sitting on existing inventory. A handful of companies have gotten conditional approvals like Netgear and Eero. Both have exemptions that run through October of 2027, which buys them time to figure out their supply chains. But those are temporary, and they came with requirements to develop a US manufacturing plan. The clock is running. Your existing router isn't going anywhere. Routers already authorized before March 23rd of 2026 can still be imported, sold, and used, and they'll keep getting security updates through at least 2027. But the new model pipeline is constrained in a way like it's never been before. It's a dumb rule, made by people who don't understand the thing they're attempting to regulate. Banning the import of a router doesn't automatically make your network more secure. A US-made router with bad firmware and no update cadence isn't safer than a well-configured open-source one. And you may have noticed that I didn't mention Ubiquiti, or Cisco. I mean, they manufacture their products abroad too, right? Yes, of course they do. I think the gray area with those brands would be that they may not be considered consumer brands, despite many of this channel's viewers having equipment from both companies in their homes. Like I said, it's a dumb rule, made by idiots. And as I've covered in an old video, linked above, the real security question always has been, who controls the software on your router? Is it still in support? And how often does it get patched? And that question leads us directly to OpenWRT. For many, the first question is, what even is OpenWRT? OpenWRT is Linux. Specifically, it's a stripped-down, router-focused Linux distribution that you can run on a device instead of whatever firmware the manufacturer shipped it with. That matters because the firmware that comes on your router from the store is almost always terrible. Part of it is that many routers don't really have a complete set of features. Just ask a bunch of the viewers that discovered that they couldn't set the DNS servers on their DHCP range when following the Pi-hole or AdGuard home tutorials. These routers may get updates and fixes for a while, but then the company moves on to the next product and your router just stops getting patches. Security holes and exploits stay open. You have no idea what it's doing in the background, and you can't really customize it. You're just trusting that it's fine. OpenWRT, on the other hand, gives you full control. Real firewall rules, VPN support, ad blocking at the network level, No telemetry phoning home to anyone. It's your router doing exactly what you tell it to do, and it's maintained by an open source community that's been active for over 20 years. While the big consumer router brands are navigating FCC paperwork and legal challenges, the maker answer to this whole situation is simple. Build your own, run open source firmware, and stop depending on anyone else's supply chain entirely. OpenWRT isn't the only option here. There's also OpenSense and pfSense, but that's for a future video. OpenWRT is the option I'm showing you today because it's often the most lightweight way, hardware-wise, to make your own router. Which brings me to the practical question. What do you actually build it on? The traditional way people get into OpenWRT is by grabbing an old router from the closet. The venerable Netgear WRT54 may have started it all, but today you can look to see if one of your past or present routers are on the OpenWRT table of hardware. And honestly, that works. It's a great way to start. I've done it, and it's awesome to give a new lease on life to equipment that otherwise would be e-waste. But here's where it also gets frustrating. A lot of older consumer routers were never designed to be reflashed. Manufacturers started locking down their firmware. Some because of an old FCC rule about Wi-Fi radio configurations, some just because they didn't want you tinkering. You'd go to flash a router and hit a wall. Signature verification, locked bootloaders, brick devices. And even when you can flash it, you're working with hardware that was already at the end of its life when you started. Slow CPU, not much RAM, maybe 8 megabytes of flash storage. Which sounds fine until you realize OpenWRT's package manager and Lucy, the web interface, together eat up a pretty significant chunk of that. You end up with a functional router, but very little room to actually do anything interesting with it. So that's the old hardware problem. It's fiddly, it's limited, and you're always fighting against hardware that wasn't designed for this. There is a better starting point. Which brings me to this little board. The Orange Pi RV2 is a single board computer, similar to a Raspberry Pi, but different. It runs a RISC-V processor, which is an open source chip architecture that's been gaining momentum lately. Momentum or not though, RISC-V is the reason why this video isn't about OpenSense. BSD just isn't quite there. Yet. Back to this board. It's got 2 gigabit Ethernet ports, Wi-Fi, Bluetooth, 2 M.2 slots, 8 cores, and 4 gigabytes of RAM. Prices have gone up since I got this board, from about $40 to $90. $40 is a great price. We'll talk about the current price in a minute. For a router project, those 2 Ethernet ports are the magic feature. One becomes your WAN port, the connection coming in from your modem, media converter, or ISP-supplied potato router. The other is your LAN port, the one that goes out to your network. That's all you need for a basic router setup. And unlike an old consumer router, you're not fighting against locked firmware or 8 megabytes of flash. You've got a proper Linux computer with real storage, real RAM, and a USB port if you want to hang external storage off of it. Running OpenWRT is like moving from a studio apartment into a house. You've got room. Compare that to a mid-range consumer router and you're looking at $80 to $150. A higher end one, $200 or more. And that's before you find out that it got 3 firmware updates and was then abandoned. The RV2, even at its currently inflated price, a case, an SD card, and a heatsink come in at about $115. Soon it should be back under $60, all in. And you'll be running software that nobody can take away from you. I'm going to show the entire process of loading the RV2 in the background. It's not that big of a deal. You download the image, you write it to an SD card with Balena Etcher. You hook a serial to USB adapter to the board and configure a couple settings with PuTTY. Then you configure OpenWRT the rest of the way through the Lucy web admin. The Orange Pi RV2 OpenWRT image I'm using is what's known as a manufacturer image. Orange Pi built it, they maintain the kernel fork it runs on, and they distribute it separately from the main OpenWRT project. What does that mean in practice? Well, it means that the kernel is a custom build that Orange Pi controls. They open sourced it, which is good, but the last commit to that code repo was a while ago. You've got a working system, but it's not getting the same ongoing attention that mainline OpenWRT gets. That has its downsides. The Wi-Fi is the most obvious casualty right now. The onboard Wi-Fi doesn't work in the current OpenWRT image. Not a deal breaker if you're Ethernet only or plugging in a USB Wi-Fi adapter, but it's worth knowing going in. What would mainline support look like? Eventually, the board's device tree files and drivers get merged into the main Linux kernel and OpenWRT build system. At that point, it becomes a first-class supported device. You get official releases, regular updates, security packages, the whole deal. That's the goal. This board just isn't there yet. Think of it as early adopter territory. It works, it's very usable, but you're in part of the project where you might need to roll up your sleeves occasionally. The RISC-V ecosystem is maturing fast, and mainline support will come. It's just a matter of when. Other downsides, some people feel constrained by a 1 gigabit per second Ethernet. I think that's about it. Keep in mind that there are plenty of great ARM-based boards from Orange Pi, Nano Pi, Banana Pi, Raspberry Pi, and Radxa that are less experimental. The point of this video was just to show you one of the out there options. So here's where we've landed. The FCC's move has put a real dent in the consumer router supply chain. And the honest answer to what do I replace my router with is increasingly something you control. OpenWRT is the firmware that gives you that control. And the Orange Pi RV2 is one of the most cost-effective pieces of hardware you can run it on right now. It's not plug and play. You'll need to get comfortable with a serial console and some command line work. The Wi-Fi situation means that you'll want to wire things up or use a USB adapter for now. Mainline support will come, and when it does, this becomes a very easy recommendation. If you want to use something more standard and supported, I completely understand. I'll be loading OpenSense onto a tiny, low-power x86 PC soon, so it's not like I'm going to keep you from seeing the various options. Forever ago, I built solutions with IP chains, IP tables, and NF tables. I started using community projects with IPCOP and have continued that with pfSense and OpenSense. Now I use a unified Dream Machine Pro, but I'm thinking of setting up VRRP, just for fun. I'd love to hear about your router experiences, perfect builds, horror stories, and anything else. Drop it in the comments and I'll read everything. If you found this video interesting or helpful, hit like, subscribe, and share this with anyone that you think might be interested in OpenWRT. If you want to support my work, please hype the video and consider becoming a member. I'm not a big deal, so it's really cheap. Or at least can be. I've added a new, ridiculous tier for anyone that really likes this content and wants me to produce it faster. And speaking of members, I want to thank the new members on the screen for their support. Thanks, and may your day be full of open source options.